Hey, what's up? Welcome to this new video. This one is paper 1-1 of May-June 2021 for Add Math paper 1. Now, with that being said, obviously, let's move on to questions number 1. So, part 1, we have to sketch the graph of y equal to this, stating the intercepts, which is the y-intercept and the x-intercept with the axes. So, one by one. So, when x is 0, what is the value of y? Let's see, y will be 5 times 1 times minus 2 and times minus 2. Let's see what will I get for this one. Of course, you're allowed to use your calculator, so 5 times 1 times minus 2 times minus 2. That will be 20 as your answer. That is the point on the y-axis. Now, when the value of y is 0, that will be on the x-axis. What is the values of x? X will be, as you can see, it will be 0 here, and we have factorization already, so x will be minus 1, x will be 2 over 3, and x could be also a value of 2. So these are the values on the x-axis. Now we just have to mark the points. For example, of course you can use a ruler to try to kind of have a scale at least to know where the values may lie. For example, I can have 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Let's say I can choose this to be 1 and 2. That'll be minus 1 and minus 2. So in this case, the point here will be what? So here we have the first point, minus 1, 0. Then we have 2 over 3. So 2 over 3 is what? 2 divided by 3. That'll be 0.666. That is 5 right here, right? 0.5. 0.6 will be here. 666 should be somewhere over here. So let's say this is the point. 2 over 3, and then we have x equal to 2 right here. Okay. Now we have to see what is the shape of the graph. Anyway, so first we also have this one. Let's mark this down. So let's say this could be value of, let's say we have, let's choose, this could be 5, 10, 20, because we don't have space, right? So let's choose that to be 10 and that to be 20. And we know on the y-axis, that will be the value of 20 over here, right? So that will be 20 on the y-axis. So you have to show all these points of intersection. Also, don't forget to label this one as well as 2 over 3, because you have to stating the intercepts. So this is good, 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 good. So I hope that makes sense. That will help you to earn some marks for your question. So now we just have to kind of draw the graph. Now we understand this one is a cubic curve. The shape usually it could be like this, for example, like this, or it could be like this, right? So we just want to know what shape this will be. For example, between those 2 points, you can clearly see the curve is up, so it will be obviously in this shape. So it should be something like this. So let's see where is the maximum point, for example. So what is the value between those two? So minus 1. Sorry, we have 2 over 3 minus 1 divided by 2. That is 5, 6, which means, let's move 5, 6 over here. So 2 over 3 minus answer, that should be minus 1 over 6. So minus 1 over 6 should be somewhere over here. It is exactly in between those 2 points. Again, you don't need to do that. It is just a way for me to kind of realize or check where is the maximum point. Will be above or kind of here over around this point. Let's check. I think it should be above, but let's check why not. So here will be this value, and we will have, okay, I don't think there's need, because you know why? It is only a sketch. That's why there's no need to do that. We can kind of know the shape already. So because the point here is on top, we realize that it will be this shape, right? It will be something like this. That will be, we need to have a maximum point. That makes sense. So try your best to make it as symmetric as possible. Okay, something like this. As you can see, this is the shape of your graph. A sketch, it doesn't need to be exact. We just have to kind of show what it looks like. That will be y equal to 5, x plus 1, 3x minus 2, and x minus 2. Again, I don't think there's a need to show the minimum or maximum point because the question did not ask you for that. But if you want to find them, you know how to find them as well by using dy by dx. Pretty easy as well. Now let's move on to part B. So here we have to, hence, state the values of x for which this is more than 0. So by observation, you can see it is more than 0. Well, so where's the graph more than 0? This is your line of 0, right? You can see it is more than 0 for this part and this part. It will be for the values of x between -1 and 2/3, and also for the values of x is more than 2. It will be more than 0 according to the graph. That will be part A or part B of the question. That is your question number 1. Now let's move on to question number 2. So here we have to find this integration, giving you an answer in the form of this, where a and b are rational numbers. Okay, so let's see how can we do this. So one by one, we can first break this down. That could be written as 1 over x minus 1. Here we have minus. That will be 5, 3, 1 over x minus 1 square dx, obviously. So first one, that will be ln of x minus 1, limits of 5, 3. That will be ln of 4 minus ln of 2. That should be ln of 4 divided by 2. That should be ln of 2. That is for the first part. Now for this one, let's see what do we have. Obviously, we can rewrite this as, this will be x minus 1 power minus 2, right? We can bring this up to make our life easier. So that will be integration of x minus 1 power minus 2, 5, 3, respect to dx. That will give you what? So first thing first, we have to increase the power by 1. That should become minus 1. Then divide by minus 1. Then we of course have to look at the limits, 5, 3. That will be what? That will be minus here. Let's take the minus outside, minus 1 outside. Inside you will first have 5 minus 1 is 4. That will be 1 over 4. And then here we have minus. And this will have what? 3 minus 1 is 2. 1 over 2. Right? So that will be minus 1 here. And here you will have 1 over 4. That should be, let's check. 1 over 4 minus 1 over 2. That should be minus 1 over 4. And that will be 1 over 4 for your answer. Now again, replace everything back in the main equation. So you will have ln of 2 minus 1 over 4. So by looking at this equation, we can rewrite this down as minus 1 over 4 plus ln of 2. So where this and this are rational numbers. And that is your question number 2. Okay, so let's move on to question number 3. The polynomial p of x, this, where a and b are constants, has factor this. So if it has a factor of this, it means if you divide by this, the remainder will be 0. So for example, if you're taking the value of, so here we have x minus 2, equate that to 0. So x will be the value of 2. So if you take the value of x to be 2, the remainder have to be 0. So let's solve this equation. Put x here as 2. You will have 8a. 9 times 4 will be minus 36 plus 2b minus 6, and that will have to be 0. So now we can form an equation from this. Let's continue here. That will be what? So here we have 8a plus 2b minus 42 have to be 0. So let's divide by 2 everywhere because everyone is even. That will be 4a plus b is equal to 21. So 42 divided by 2, that will be 21. So that will be my equation number 1. Now, what else? So here we have the remainder is 66 when you divide by this one, which means equate that to 0, which means the value of 3 is x is 3. So when the value of x is 3, the remainder will be 66. So that will be p of 3 will be 66. Replace back in your equation, you will have 27a. 9 times 9 will be minus 81 plus 3b minus 6 have to be 6, 6. Let's try to simplify this. You will have what? 27a plus 3b, that will be what? 6, 6 plus 6 plus 81. That will be 153. That will be my equation number 2. Now obviously we have two equations right here. We can solve simultaneously to find the values of a and b. Here I can make a or b become the subject, so b will be 21 minus 4a. Replace b in this one, you will have 27a plus 3b. b is also 21 minus 4a. That will be 153. That will be 27a plus 63 minus 12a have to be 153. So 27 minus 12, let's see, 27 minus 12, that will be 15. And that will be 153 minus 63. That will be 90. So a will be the value of 90 divided by 15. That will be 6. So finally, b will be 21 minus 4 times 6. That will be 21 minus 24. That will be minus 3. A will be 6 and b will be minus 3. Okay, these will be the values of a and b, as you can see, step by step. Now for part b, we have to use the values of a and b. We have to show that p of x is equal to this, where q of x is a quadratic factor, so pretty easy. Right now we know that p of x is equal to what? A is 6x cubed minus 9x squared. B is minus 3x minus 6. So we have to express this in this form, but we know that x minus 2 is a factor already given to you by the question. So we just have to perform long division to see what is the remainder, see what happens, or the quotient. So in this case, let's do that. You will have 6x cubed minus 9x squared minus 3x minus 6. That will be division by x minus 2, which is a factor of this polynomial. So now to make x become 6x cubed, we have to multiply that by 6 first, and then x squared. That will be 6x cubed minus 12x squared. And this will go away, obviously. Minus 9 plus 12 should be 3x squared minus 3x minus 6. Now to make x become 3x squared, you have to multiply by plus 3x. That will become 3x squared minus 6x. That will go away. Now minus 3 plus 6 will become 3x minus 6. Now my x to become 3x have to multiply by plus 3. That will become 3x minus 6. So the remainder will be 0. So here you have p of x have to be x minus 2 times this one, the quotient, and that will be your value for q of x, which is a quadratic function. Now for part C, we have to show the equation has only one real root. Okay, so let's show that. So this is the equation right now we have, which is p of x is x minus 2. We have 6x squared plus 3x plus 3. Equate that to 0. So solving this equation will be what? So the first solution will be x minus 2 will be 0. X will be the value of 2. That is one of the solution. Now for this one, it is a quadratic function. Let's see if we can solve this one or not. So let's see if we have a real root for this one or not. So check. This is a, b, and c, right? So b squared minus 4ac will be what? That will be 9 minus 4 times a times c. So 9 minus 4 times a times c. That will be minus 63, which is less than the value of 0. So you can say since b squared minus 4ac is less than 0 for this one, we don't know real roots. We don't have real roots from this part of the equation, so only one real roots we have, which is x equal to 2. And that is proven. Question for number 3. Now let's move on to question number 4. So the first 3 terms of an expansion, in this expansion, in ascending powers of x can be written as the following. Now where a and b and c are integers, which means they are whole numbers. So we have to find that value. So one by one, As you can see, we only stop at the term in x squared, so this is all we need, right? Now let's first expand this. For example, if you would expand this, you will have, so here we have 3, choose 0, that will be a, and that will be x, that will be 0, that will be 3, 3, choose 1, that will be a, that will be x, that will be 1 here, that should be 2, 3, choose 2, that should be a, x, that will be 2, that will be 1, and finally 3, choose 3, that will be a, and that will be x, here we have 3, that will be 3, and that will be 0. That is 1 times a power 3 times 1 plus 3 times a squared times x plus 3, choose 2, that is 3 times a times x squared, that will be 1 times x cubed. So that will give you a cubed plus 3 a squared x plus 3 ax squared plus x cubed. Okay, this is the expansion for this one. How about this one? Now again, we only care about the first 3 terms. We can just expand the first 3 terms of this one as well to see what happens, right? You will have, first one will be 5, choose 0, that is 1 minus x over 3, 0 here, that will be 0 here, we will have 5, and plus 5, choose 1, that will be 1 here, that will be minus x over 3, here we have 1, that will be 1, and that will be 4. And we can stop right here because obviously we only need a term until x squared, right? That will be 2 here, 1 here, and minus x over 3, that will be 2 and 3. That will be 5, choose 0, that should be 1, right? So 1 times 1 times 1, plus 5 times 1 times x over 3, plus 10, plus 1, x squared over 9. That will be 1 minus 5 over 3, x plus 10 over 9, x squared. Now, so basically what we're doing is we're taking the first expansion and times this one. So the first one is what it is, a cubed plus 3a squared x plus 3a x squared. Now again, we can stop at x squared because again, we only have until x squared over here. We don't need to go too much, right? Multiply by the other term will be 1 minus 5 over 3 x plus 10 over 9 x squared. So one by one. So first you will take this one, multiply by everything here. That will become 1 times, that will be a, this, minus 5 over 3 a cubed x plus 10 over 9 a cubed x squared. Now for this one, that will be this and this because we don't need x power 3, only power 2. That will be times 1 first, that will be plus 3a x 3a squared x, this will be minus 5 over 3 times 3a squared x squared. Now the last one will be this one. We only have to multiply by this one because the rest will be kind of irrelevant. So plus 3ax squared. Okay, great. Now we have to simplify. The first term is obviously a cubed, right? There is only one with no constant, obviously with no x. Now the rest will be, this one is x and this one has x. We can factorize them together, so that will be plus 3a squared minus 5 over 3 a cubed x. Right, and then for this one, you will have, this will cancel out obviously, you will have plus 10 over 9 a cubed minus 5 a squared plus 3a factorize x squared outside. Now we know that if you expand this, you have the first 3 terms as follows. Now, but we also know it is given to you that the first 3 terms are as follows, so we can find that value. So that should be giving you 27 plus bx plus cx squared. So we have to find the value of a, b, c as follows. So just by comparing, so we know that a cubed have to be 27, which means a have to be cubic root of 27, and that should be your value of 3. From here, b have to be 3 times 3 square minus 5 over 3, that will be 3 cube. So 3 times 3 square minus 5 over 3 times 3 cubed. That will be minus 18. Okay, that is value of b. And for this one, value of c, 10 over 9. So 10 over 9 times 27 minus 5 times 9 and plus 3 times 3. That should be minus 6. So these values are all integers. As you can see, value of a will be the value of 3, b will be minus 18, and c will be minus 6. They're all integers. That will be the value of a, b, and c, and that is your question number 4. Now let's move on to question number 5. So here we have functions f and g are defined by the following functions or expression. Here you go. X can take any real values. Good to know. Part 1. We have to find the range of f. The range of f means what is the y value of the function that it can go. For example, we can look at the graph for that to know. So this is the axis. This is the x-axis. This is the y-axis. Now x can take any value according to the question. So here a good question we can ask is, what is the minimum point of this curve? Because you can see it is a minimum curve because the coefficient of x squared is 1. It is positive. You will have to have this shape. Now what is that minimum value we can find? So as you guys know, there's many ways to do that. One of the ways is obviously to find dy by dx or f prime. That will be 2x plus 4. Then we equate that to 0. That will be x will be minus 2. Y will be what value? Replace back in here. You will have that will be minus 2 squared. That will be 4 minus 8. That should be minus 4. So which means the minimum point will be minus 2 minus 4 will be somewhere over here. And the graph obviously have a shape like this, right? Something like this. Look, it is only a sketch. I don't know exactly that's the shape, but the main point I'm trying to make is that will be the minimum value of the curve. Now the range is just the y values, the up and down values, right? As you can see, the range of f is always more than this value, more or equal to this value here is minus 4. That will be your answer for part A. Now the range is the y values. Always recall this, range is the y values, and the best way to find this is by looking at the graph. And you can see the graph is always more than this value. Otherwise, it will always be increasing here as the value of x increases. Okay. Now part B, write down the range of g. So range of g. So let's see for this one. Again, one of the ways to find that is we can look at the graph. It is one of the ways. If you guys don't know how to find this exactly, because usually we have to look at this value here. But let's see what does the graph shows us. For example, so we have the value of g of x is equal to 1 plus this. Now this is the, and that will be x. Now when the value of x is 0, what is the value of g of x? That will be 1 plus exponential power 0. That should be value of 2. The main idea is that what's going to happen is we will have an asymptote here at the value of y equal to 1. This is the value over here, and the graph will always have a shape like this. As you can see, the range will be the y values, and you can see the graph will be always, g have to be always more than the value of 1. So that's the reason why they ask you to write this down. It is pretty easy, this value here, right? But this is the idea behind the question, why it is always more than 1, because we look at the graph. The y values here is always going to be more than this value. That's why it is more than 1. Now for part C, we have to find the exact solution for this one, giving your answer as a single log. So pretty easy, one by one. So let's first find this one. What is f g of x? That will be f g of x. That will be g of x squared plus 4 times g of x according to the functions. Now we just have to replace. That will be 1 plus exponential 2x squared plus 4 times 1 plus exponential 2x. That will give you what? 1 plus 2 exponential 2x plus exponential 4x plus 4 plus 4 exponential 2x. Equate that to 21. So let's solve this. So we have this plus, sorry, we don't have this actually. So we have this plus this, that will be 6 exponential this. Here we have exponential 4x. So here we have plus, obviously. Here we have plus 5 minus 21 have to be 0. Now let's simplify. You will have what? Exponential 2x square plus 6 exponential 2x. 5 minus 21, that will be minus 16. Have to be 0. So in this case, we can try to solve by using a substitution. Let exponential to power 2x, sorry, let this one equal to u. That will be u squared plus 6u minus 16 have to be 0. Now we can factorize. Let's see what happens. You will have u times u. 16 is 8 times 2. If you want to have plus 6, you have plus 8 minus 2. So u can be minus 8 and u can be the value of 2. Now again, we're trying to find the value of x. Replace back. You will have exponential 2x. That will be minus 8. Obviously, it is not possible, right? It is invalid. It's always going to be more than 0. Now for this one, that will be exponential. Have to be the value of 2. So 2x have to be ln of 2. And then x will have to be half ln of 2. Is also same as ln of root 2. That is your value of x. That is the exact solution, only one solution, no s, for your value of x as a single log. That will be part 5 or question number 5 for functions question. Now let's move on to question number 6, part 1. We have to find out how many different 5-digit numbers can be formed using the numbers 1, 3, 5, 6, 8, 9. So available 6 numbers. Right, so we have 6 numbers available. We want to form a 5-digit numbers. So for this kind of questions, obviously the order does matter, and because of that, it will be a permutation question. That will be 6 available numbers. They are all different. Permutate 5 of them. That will give you what? 6p5. That will be 720. That will be one way of doing the question. Now the other way is very simple as well. As we have seen before, we have 6 numbers. We have to form a 5-digit number. So we have to have 1, 2, 3, 4, 5 space. Now, for the first position, I can choose anything. I will have 6 options. Let's say I choose 1. For this one, I will have remaining 5 options. Let's say I choose 3. Remaining 4 options. Let's say I choose 5. Remaining 3 options. Let's say I choose 6. And 2 options. Let's say I choose 8. That'll be 6 times 5 times 4 times 3 times 2. That'll be also give you 720 as well for the answer. So 2 ways of doing the same question. Now for part 2, how many of these 5-digit numbers are odd? So let's see. So we have the numbers 1, 3, 5, 6, 8, and 9. So this is odd, 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 and odd. So we want to form a 5-digit number, so we have to have 1, 2, 3, 4, 5. Now we understand that a number is odd when it ends with an odd number. That's how we think about this question when we deal with permutation. So the last number here have to be odd. That's the main idea. Now, as you can see, we have 4 options. So 4 options for the last number. Let's say we choose 1. Now once this is fixed, we can forget about it. Now for the first one, we can choose anything. We will have remaining 5 options. Let's say we choose 3. Remaining 4 options. Let's say we choose 5. Remaining 3 options. Let's say we choose 6. Remaining 2 options. Let's say we choose 8. That'll be 5 times 4 times 3 times 2 times 4. That will be 480 as your answer. That will be part 2 of your question. Now for part 3, how many of these 5 numbers are odd? So we have 2 conditions here, and more than 60,000. So pretty easy. Let's find out. Numbers 1, 3, 5, 6, 8, and 9. So here we have odd, 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 and odd. And we also understand for a number to be more than 60,000, it needs to start with at least a 6, right? So the first number have to be at least a 6. So 6 or more, it could be 6, 8, or 9. So here you can see we have overlapping conditions where we have the green and the blue meets. We have to look at case by case. The first case, what if we start with 6 or 8? So here we don't have any overlapping. What if we start with 6 or 8? Now again, we want to form a 5-digit number, so we have to have 5 space. Now if you want the number to be odd, we have 1, 2, 3, 4 options, right? Let's say we choose 9. Now in this case we have 2 options to start. Let's say we choose 6. Now 6 is gone, so 6 is gone and 9 is gone. For the rest, for this one I will have remaining 1, 2, 3, 4 options. Let's say we choose 1. This one I will have 1, 2, 3 options left, and then 2 options. Say we choose 5. Now if you start with 6 or 8, you will have 2 times 4 times 3 times 2 times 4. That'll be 192. Now second option is you can start with 9, right? Because we can start with 6 or 8 or 9. Now we take this separately because we have the green and the blue meeting. We have 2 conditions overlapping. That's why we take this case separately. Okay, so again we have 1, 2, 3, 4, 5 because we want to form a 5-digit number. Okay, now if you start with 9, we put 9 here and we have only 1 9. That is only one option of starting. Great, 9 is gone. Bam. Now to form an odd number, we have to end with an odd number, so you have remaining 3 odd numbers, so 3 options. Let's say we choose 1 is gone. Then the rest could be just anything. For this one you will have remaining 4 options. Let's say we choose 3. Remaining 3 options, let's say we choose 5, and the remaining 2 options, let's say we choose 6. That'll be 1 times 4 times 3 times 2 times 3. That will be 72. So this plus this will be what? So 192 plus 72, that will be 264 as your answer for part 1 of your question, part A. Okay, now let's move on to part B of your question. Given that we have this, find the value of n. Now again, it is not too hard. I would say we just have to use what is given to us. So what do we know about this? We know the formula for this one is what? For example, when you have n combination r, that will be what? N factorial over n minus r factorial times r factorial. So that's the main thing we have to use to solve this equation. For example, what is this one? What is n combination 4? That will be n factorial over the value of n minus 4 factorial, and then 4 factorial is what? That is 24. That is this one. How about this one? Oh, this one, actually. We have n plus 1, combinations 5. That will be n plus 1 factorials over n plus 1 minus 5 factorial times 5 factorial. That will be n plus 1 factorial over the value of n plus 1 minus 5 is n minus 4 factorial, and 5 factorial is simply the value of 120. Now we just have to replace back in the main equation. So we have 45 times, that'll be this, that should be 24, n minus 4 this, that will be n factorial. So here we have n plus 1 actually, my apologies, that will be n plus 1, and this will become n plus 1 factorial over the value of 120 n minus 4 factorial. Now simplify. So these two will cancel out, obviously. Divide by 24 on both sides, this will become 1, and this will become what? So 120 divided by 24, that will be 5. Then we can just cross multiply, send this on top. 45 times 5, that will be 225. So 225 n factorial is equal to n plus 1 times n plus 1 factorial. Now we have to understand the concept of factorial to solve this question. For example, what is 2 factorial? It is 2 times 1. Now what is 3 factorial? It is 3 times 2 times 1, but it is also 3 times 2 factorial. For example, what is n plus 1 factorial? It will be, first number is the first, that will be n plus 1, times, we have to minus 1, that will be n factorial. So that will be n plus 1 times n factorial. So replace it back in your equation, that will be 225, n factorial will be n plus 1 times n plus 1 times n factorial. Now this and this will cancel out, obviously. Here you will have 225. This will be n plus 1 square. N plus 1 will be root of 225. That will be what? 15. Here you go. N will be the value of 14. Okay, and that will be your question, part B, for question number 6. Now let's move on to question number 7. So in this question, all lengths are in meters and time t is in seconds. So first thing first, we have the displacement time graph. Fair enough. What do we need to do here? So the question is, the diagram shows the dt graph for a runner between the time of 0 till 40. As you can see here, we have time for the runner. Now part 1, we have to find the distance the runner has traveled when time is 40. So what is the distance he has traveled? Let's see. Pretty easy. We just have to find distance traveled, not the displacement, distance traveled. It will be this part and this part, right? So first thing first, it will be this part, which is 50 in this direction. So 50 plus, it went down all the way here, that will be also 50 plus 50, and this will be also, that will be 10. So here we don't care about the sign or anything, we're just trying to find the distance traveled. At first, from 0 to 10, it traveled in one direction. It traveled for 50 meters. From 10 to this one, 35 maybe, it traveled back to its initial point, so another 50. And then it crossed the point and traveled in the opposite direction. That's why we have negative here for another 10. So plus 10. That should be 110 as your answer. That will be part 1 of your question. Now for part 2, on the axis below, we have to draw the corresponding VT graph between this and this. So again, there's a few parts we have to look at. So the first part is this and this, 0 and 10. Now we have to understand something when we have to do this, is that the gradient of the dt graph is equal to the velocity. So that's the main concept behind these two graphs. So what is the gradient of this one? Pretty easy. It is the height divided by base. The height is 50 divided by 10 will be 5. So pretty easy. 0 to 10, that should be 5. So these two will be drawn by a straight line, because you can see there's a constant increase. It is a straight increase. The gradient is constant. Because of that, the velocity will be constant as well at this value of v equal to 5. Now what's next? Next thing you can see, we have from 10 to 40, we have also a decrease here, which is constant, which means the value of v will also be a constant value. So v will be the height divided by the base. The height will be 60, base will be 30. So 60 divided by 30, that will be the value of what? Of 2. If that's correct. Because here 40 minus this will be 30, that's the base. Height will be 50 minus 10 will be 60. That'll be 2. So 2 will be somewhere over here. So 10 to 40 will be here. And that will be your VT graph. And that is your question, part A for question 7. Now let's move on to part B of the question. So a particle P moves in a straight line such that its displacement S is given to you. No, it is not given to you, actually. It is given to you by S. Now we know that the acceleration, which is A, is given to you by 2t plus 4 power minus half. Now we have to find what? We have to find the value of v at t. So pretty easy. We understand that v is equal to integration of a respect to dt. Replace. That will be 2t plus 4 power minus half dt. That will be 2t plus 4. Increase by 1, that will become half. Divide by the power. Then divide by d by dx of this value, that will be 2. Of course, plus c for the constant of integration. So this and this will cancel out, so you have v, that will be 2t plus 4 power half plus c. Now let's find the value of c. We know when the value of t is 6, v is 9, so that will be 9. 2 times 6 will be 12 plus 4 is 16, 16 power half plus c. So c will be 9 minus 4, and that will be 5. So finally, v will be 2t plus 4 power half plus 5. This is your value of v at time t. Now let's move on to part 2 of your question. Now given that s is equal to 1/3, when t is this one, find the value of s. So s is equal to integration of the value of v with respect to dt. Replace, that will be 2t plus 4 1/2 plus 5 dt. That will be, first increase the power by 1, that will become 3/2, divided by the subpower, and divide by d by dx of the value inside, that will be 2. And plus 5t, plus the constant d right here, that will be s. Now simplify, obviously, this and this will cancel out. Have s is equal to 1/3, 2t plus 4, 3/2, plus 5d plus d. Now we have to find the value of d. We have to use this one. So s is equal to 1/3. When t is 6, that will be 16, 3/2. 5 times 6 will be 30 plus d. So let's find the value of d. Right. So one thing we can do, we can simplify, right? So 16 power 3/2. That will be 64. So we have 1/3 is equal to 64/3 plus 90/3 plus d. Let's see what happens. So we have 64 plus 90, this, 1 minus answer, that should be this, divided by 3. That will be this. So d will be the value of minus 51. So let's check again. Send everything to the left hand side. So 1/3 minus 64/3 minus 90/3. That will be minus 51. So finally, the value of s will be 1/3, 2t plus 4, 3/2 plus 5/t minus 5/1. And that is your value of s in terms of t. And that is part B of your question. Let's see what happens here. So here we do not have to use a calculator. However, we can always check using a calculator, and we just have to show all the steps of our work to get the full marks. So a curve have equation this. Okay, the x value of a point A on the curve is this. Okay, so we have a point A, and the x value, we have a y value, x value is this. Okay, now part 1, we have to show that the coordinates of A can be written in the form of this. Okay, let's see. How can we do that? Pretty easy. So first thing first, we can re-express x as this. That will be 3 plus 1 over the value of 2 minus root 3. Now we have to multiply by its conjugate. That will be 2 plus root 3, 2 plus root 3. That will become what? Root 3 plus 1 times 2 plus root 3. And here you will have, because it is a minus b times a plus b, it is same thing as a square minus b square. So we have to understand it is the difference of squares, right? When we have a square minus b square, it is same thing as a minus b and a plus b. So here we have this one, we have it is same as this one. That will be 4 minus 3. That will be, now we expand this, that will become 2 root 3 plus 3 plus 2 plus root 3 over the value of 1. That will be 2 plus this, that will become 3 root 3 plus 5. That is the x point. Now you want to find the y value, we have to replace back in the equation, right? As you can see here, we have x squared. So let's find the value of x squared. What is x squared? That will be plus 5 squared. That will be 9 times 3 plus 30 root 3 plus 25. That will be 9 times 3 plus 25, that will be 52, 30, root 3. So we place back in the main equation to find the value of y. Obviously, it is going to be 2 minus root 3. X squared is 52 plus 30 root 3 plus x. X is 3 root 3 plus 5 minus 1. That will be 2 times 52. That will be 104 plus 60 root 3 minus 52 root 3 minus 30 times 3. That will be plus 3 root 3 plus 4. It is just simplifying right now. We just have to make sure we don't make any mistakes while we simplify this expression. So one by one. So here we have root 3, and root 3. Let's see what happens. So we have 60 minus 52 plus 3. That'll be 11. So 11 root 3. Now here we have constant, and constant. So here we have 104 minus 90 plus 4. That'll be 18. So 18 plus this. So finally, we have the answer right here. So the point A will be x value will be 3 root 3 plus 5. Y will be 18 plus 11 root 3. But the values of P, Q, R, and S are integers. Integers are whole numbers, and these are whole numbers as well. And that will be part A of your question. Now let's move on to part B of your question. So here we have to find the x coordinate of the stationary point on the curve. So pretty easy. We understand that at the stationary point, what happens? dy by dx have to be 0. So let's first find dy by dx, right? That's the main idea. So y is given to you by 2 minus this x squared plus x minus 1. So dy by dx will be 2 x plus 1, that becomes 0. Equate that to 0 to find the stationary value. That will become 2 minus root 3 x, that will be 2 here obviously, equal to minus 1. So here you have 2 minus this, that will become minus 1 over 2. And finally x, we could have just sent the whole thing right away, so I don't know why I did that. That will be minus 1 over the value of, here we have 2 minus root 3, which is 1 over 4 minus 2 root 3. So we just have to simplify this in the form of this. So step by step, obviously you have to multiply by its conjugate. That will be 4 plus the value of 2 root 3 and 4 plus 2 root 3. That will give you minus 4 minus 2 root 3 over the value of, that will become 16 minus 4 times 3. Let's see, what do we have? So that will become minus 4 minus 2, this 16 minus 12 will be 4, divided by 4, that will become minus 1 minus half root 3. And this is your answer for part B of your question for the x value, or for the x coordinate of the stationary point, in the form of this, where a and b are rational numbers, which means exact numbers. That will be question number 8. Now let's move on to question number 9. So here we have to write the 6xy plus 3y plus 4x in the form of this. So let's see how can we factorize this. So step by step. So let's try it, because I don't know yet. Let's try what can we do. So have the value here. We have y and y. Let's try to factorize y first. Here we have 6 and 3. Factorize 3. You will have 2x remaining plus 1. Here you have 2 in common. That will be 2x plus 1. Now this and this are the same. We can factorize this outside. You will have 2x plus 1. That will be remaining 3y plus 2. So by comparison, that will be simply as 2x plus 1 times 3y plus 2. So I hope it makes sense, because if you realize here, what we did is pretty easy. We broke this down into two pieces. For example, I wrote 6xy plus 3y, and then space 4x plus 2. Now we'll look at this first and this afterwards. So for this one, we can see common we have y common we have 3. Remaining will be 2x plus 1. Right, here we have plus. Common we have 2. That will be 2x plus 1. But then these two are the same. We can also refactorize again. You will have this as your answer. That is part 1 of your question. Now for part 2, hence, using that information, we have to solve this equation. So let's see, by comparison, that is 6xy plus 3y plus 4x plus 2 is 0. So it is the same thing as this. We just have to replace the value of x by this and y by this. If that makes sense. So after factorizing, you will have 2 cos x is sine theta plus 1, and then 3 cos theta plus 2 equate to 0. So here we will have a few possible values. For the first one, sine theta will be minus half, and here we have cos theta will be minus 2 over 3. For the first one, because sine is negative, it will be in the third quadrant, and in the fourth quadrant, that will be 180 plus the value of theta. This will be 360 plus the value of theta. But again, let me use a fake angle here because the value is negative. I don't want to do this directly. Let's call this alpha. Because it is negative, as you have seen before, the way I do my questions when it comes down to negative values, I like to work with a fake angle first. Let's first find alpha. Alpha will be sine inverse of the positive value here. That will become 30 degrees. So finally, theta is equal to 180 plus 30 or 360 minus 30. That will be 210, and here will be 330. That is part 1. Now same thing for this one. When cos is negative, it will be in the second quadrant and the third quadrant. That will be 180 minus alpha, and this will be 180 plus alpha. So alpha will be cos inverse of the positive angle. Cos inverse 2 over 3, that will be 48.2 degrees. So finally, theta will be, according to the quadrants, will be 180 minus 48.2, that will be 131.8, and we have 180 plus 48.2, that will be 228.2. So here you can see we have 4 values available for theta. So theta will be 131.8, 210, 228.2, and then we have 330 degrees. So that will be your answer for part 2 of your question. I guess the only tricky part here to understand is that when you have negative, usually I don't use the direct method. I like to go through the quadrants method. As you can see, I will first find the angle when it is positive, then look at my quadrants, find the values. Same thing here. I will first find the value of the fake angle here, which is for the positive value, and then use the quadrants to find the actual value. So this is my method. If you guys want to use that, definitely go ahead. But if you guys have your own method, if you prefer your own method, you can also use your own method. That is part A of your question. So now let's move on to part B of the question. So here we have to solve this equation for the value of sigma between minus pi and pi, which is in radians. Give your answer in terms of pi. Fair enough. So step by step, we understand that what is sec? Sec is 1 over cos. That will be. So we will have sec. Let's call this y for now. Y is equal to 2 over root 3. So cos of y is the same as root 3 over 2. Right. So here, because it is positive, it will be in the first quadrant and in the fourth quadrant. First one will be simply the angle y. This one will be simply the 360 will be 2 pi minus y, because here we have to work with radians, right? So y will be cos inverse of root 3 over 2. So because here it is positive, we can find the value directly. So cos inverse of that will be 30 degrees, which is equal to pi by 6 radians. But also this is the first angle here, which is also equal to 2 pi minus 1 over 6. That will be 1 5 over 6 pi, which is 1 times 6 plus 5 is 11 over 6 pi. Now this is the other value. Now let's see what can happen here is that we can see the domain of sigma is between minus this and this. Again, here we have 2. So let's try to play with the possible values, right? Because here we have 2. Let's try to add 360. So let's try to add 360 or 2 pi, right? You will have 1 over 6 plus 2. That will be this, which will be 13. This or this one plus 2. That will be 18 plus 5. So 3 times 6, 18 plus 5. That should be 23 over 6 pi. This is after adding 2 pi. Now, because we also have a negative side for the value of this, let's try to minus 2 pi to these two values. You may also have 1 over 6 minus 2. That should be minus 11. This pi, and this one minus 11. So 11 over 6 minus 2. That should be minus 1 over 6 pi. Now again, the reason why I'm doing this is because to explore the other possible values. Because you can see here we have 2 revolutions, so that I can try and see if I'm not missing any values. And the reason why I'm also minusing the values of 2 pi because of the domain, you can see we also have values on the negative side. That's the reason why. So step by step, again, how did I find this? We had to add 2 pi and 2 pi. And the reason why is because of the 2 here in front of sigma. Now, how do we find these two? By minusing, by taking off 2 pi and 2 pi. Because the domain is also on the negative side, we want to check if we have values on that side or not. That's the idea behind this. So now, the answer is obviously not y. Y is equal to 2, this, minus this. So plus this, actually, right? So let's first find 2, this one. That will be everything minus this. That will be 1 over 6 minus 1 over 4. That will be minus 1 over 12. 11 over 6 minus 1 over 4. That will be 1. So that is 1, 7. So 1 times 12 plus 7 will be 19 over 12. This. And then we have 13 over 6 minus 1 over 4. That will be, so 1, 11, so that should be 23 over 12 pi. And 23 over 6 minus 1 over 4. That will be what? 36 plus 7, that should be 43 over 12. Yeah, 12 pi. Again, I'm just trying to make this become subject, so by removing this value, right? So we have to minus the value from every of those values. Step by step. It is kind of painful. You can see it is really annoying, but it is what it is. Minus 11 over 6 minus 1 over 4, that will be minus, so 2 times 12 is 24, minus 1, plus 1, sorry, that will be 25, so minus 25 over 12, this, and this one finally, minus 1 over 6, minus 1 over 4, that will be minus 5 over 12, this. So now we have to make this one become subject, so divide by 2 everywhere, we have 1 over 24, this, 19 over 24, this, and here you will have 23 over 24, this, 43 over 24, this, minus 25 over 24, this, and minus 5 over 24, this. Now we know the value of sigma is between the values of minus pi and pi. So we have to choose which values fall inside this domain. So this is okay, it's inside. This is okay as well, too much, and okay as well. So we have 4 values. Sigma will be minus 5 over 24, this, minus 1 over 24, this, 19 over 24, this, and finally 23 over 24, this. That will be in terms of pi for your answers. Again, it is not tough, it is just lengthy, and it is easy to make mistakes by forgetting values that we may have in this equation. As you can see, the main thing to do here was these two options. Because of this and of this, we have to try and see if you have other values. And that will be your question number 9. Right, now let's move on to question number 10. In this question, all the lengths are in centimeters. So let's see, what do we have here? The diagram shows a shaded shape. Okay, I don't see the shaded position. I'm not sure where is the diagram shaded. So I have to check to make sure that it is the one that I'm looking at. So I hope that will be so the arc AB. So let me check real fast which part is shaded, because I don't see, I guess my printer did not print this correctly. I have to check which part is shaded. Just give me one moment, I'll be back with you. Okay, I see. So it's the whole thing. The whole thing has been shaded. So obviously, I don't know why I didn't see that, but the whole thing is shaded. Everything. Now, the arc AB is a major arc of circle, center O. Okay, radius is 10. This is 10. This is also 10. Right. Now the line of AB is of length 15. So this two is 15. Okay, which means this is half and half. Right. Now the line OC is of length 25, good to know. The length of AC and BC are equal. So AC, these two and these two are equal. So these two are the same. Right. Now what else do we need to know? So we have to show that the angle AOB is 1.7. So what is AOB? It is this value over here. It is 1.7. So pretty easy. We can use cosine rule. As you can see, we have a triangle AOB. We know these two sides and this side as well. We can use cosine rule. So that will be cosine of the angle O. That will be 10 square plus 10 square minus 15 square over the value of 2 times 10 times 10. That will be this, and we have to solve. 10 square plus 10 square minus 15 square divided by 2 times 10 times 10. That will be this. Finally, sorry, mistake here. That will be 200 minus 15 square divided by 200. Cos inverse of that will give you your answer, which is, so here we have to use radians divided by 180. That will be, sorry again, 10 square plus 10 square minus 15 square divided by 200. I use radians. Cos inverse of answer, that will be 1.696. That will be 1.70, correct to 3 SF for the value of the angle right here. Again, it is just using the cosine rule and using radians for your angle. Okay, that will be angle AOB. That will be 1.7 as shown as required to 2 decimal place. Now part B, we have to find the perimeter of the shape. So how would you find that? We have to find the distance around the shape. So pretty easy, 1 by 1. This is 90 over here. What is this length? This is 15. That will have to be 7.5. This is 25. So let's see, what can we find? We have to find this one, and this one. So let's first find this one. What is the length of this one? If this is 1.7, what is the value of this one? Pretty easy. It is 2 pi minus 1.7. That will be this value. Now we know that the arc length is equal to r times theta, the angle. R is 10 times 4.583. That will be 45.8. So AB here will be 45.8. Okay, so what else? So we have to find this one and this one. So let's see, how can we find those values? So let's first find this one. So let's see, is there any easier way to find this or not? Because we know the value of the angle over here. Here we have 10. Here is 90 here. So we are trying to find this length and this length. So we can first find which one can we find. It is 4 marks. Let's see if it is worth the pain or not. It is 4 marks, so it is pretty much it is a lot of marks. So we understand that these two are the same, so we can just find one of them and multiply by 2 in the end. So let's find this one. How would you find the length of AC? So we can see the whole thing here is 25. We have to find this length. So to find this, we must first find this one. How would you find this one? So let's see. So we can do what? Let me think if there's any easier way. So no, I cannot see an easier way. So let's go with this one. We have this triangle here. This is 90 degrees. We can find this one by using the Pythagoras theorem. So O, let's call this x. So OX can be found by using the Pythagoras theorem. That will be square root of 10 square minus 7.5 square. So 10 square minus 7.5 square, that will be 6.614. If this is 6.614, the whole thing here will be what? 25 minus 6.614, that will be what? 18.3856. Now, if this is 18.3856, this is 7.5, this can be found by using again the Pythagoras theorem. So AC will be root of 7.5 square plus 18.38 square. So square this one plus 7.5 square. Root of that will be 19.856. So correct to 3 SF, that should be 19.9 for this one. But anyways, let's add everything together. So we have to add this one. So 45.8 plus 2 times this and this, that will be 19.856. So 45.8 plus 2 times 19.856, that will be 85.5. That will be centimeters for the length of, for the perimeter of the shape. Now in the end, we have to find the area of the shape. So area, how would you find the area? So let's see. It is in 2 pieces, I guess, in 3 or 4 pieces. Let's check what can we do. So we can first find the area of this triangle, and then multiply by 2, and then find the area of this one. So one by one. Let's first find the area of this sector here for this one. That will be half. All square is 10 square. Angle is theta. Theta will be 2 pi minus 1.7. That will be 4.583. That will be half times 10 square times the 4.583. That will be 229.15. So that is the area of this one. Now to find the areas of this and this, we understand that this and this are the same, so we can just find this one for the area. So pretty easy. If you turn this way, you can see it is a triangle. How would you find the area of a triangle? Pretty easy. It is half times base, which is 25, times the perpendicular height, which is 7.5. That will be half times 25 times 7.5. That will be this area of one of the triangle. Now we have to multiply by 2 to find both. So times 2, that will be just be 187.5 for area of both of the triangles. So this plus this will be area of the whole thing. Let's add them together. That will give you what? So on top you have 229.15 and plus 187.5. That will be 416.65. That will be 417.0. That will be centimeters square, correct to 3SF. That will be your area of the shape, correct to 3SF. And that will be your question number 10. And this is the last question of this paper. I hope that was somewhat helpful. As always, thank you for watching. I will see you soon.